Yeah. Hello, everyone. Good evening. Welcome back to 360DigiTMG's fourth day of domain analytics program. Since 3 days, we've been discussing what are the applications of machine learning when it comes to healthcare analytics. The very first day, we have discussed what are the changes that we can do when it comes to healthcare analytics in order to improve the performance, so that it will be easier to process some data, data entries, and when it comes to reading the data. There are so many applications that we have gone through: automation, clustering, something like that. And in the very second day, we have learned about what are the phases we'll be having when it comes to data science project. That is CRISP-ML. We have discussed the phases of CRISP-ML, cross-industry standard process in machine learning quality analysis. So we have discussed that too, and we have discussed what are the models we'll be having. What is supervised? What is supervised? We have discussed unsupervised. What happens when we going for the model which is supervised? Whenever you have labeled data in your data frame, that is, in that case, we'll be going for supervised. When you don't have a labeled data, in that case, we'll be going for unsupervised. What are the steps we'll be following when it comes to supervised? What are the steps that we are following when it comes to pipeline? In simple language, what are the pipelines when it comes to unsupervised and supervised? We have discussed. On third day, we have discussed about the pre-processing techniques. Pre-processing. So whenever you gather data, it won't be perfect. In that case, you have to do some cleaning in order to use that particular data for your model, machine learning model. So what are the steps we'll be following when it comes to pre-processing? There are so many techniques, like very first one, typecasting. Duplicates. Have you found any duplicates or not in your data? Outlier treatment. Categorical loop encoding techniques. There are so many. We have discussed what are the uses of typecasting, where exactly we'll be using the typecasting, duplicates, where we'll be using the duplicates values, everything, encoding, when we will be doing the encoding, all those things we have discussed in the last session. And we have also gone through what happens if it is unstructured data, something like unstructured data. Textual, you can say textual. What happens when you have a textual data? How we are doing the pre-processing when it is unstructured data, like tokenization, stemming, lemmatization. All those things we have gone through. How we going to apply that? We have seen that. So in this class, we will be going through hierarchical clustering. We'll be taking one use case scenario, and we'll be applying the one unsupervised learning. In this case, we are taking the k-means algorithm. We will be taking the k-means algorithm, and then we will be applying the one use case scenario and try to form the clusters. How we gonna decide based on the features. Yeah. Before going to the use case, first we'll learn what is the unsupervised learning, what is the k-means algorithm, how exactly clusters are formed when it comes to k-means algorithm. Like we discussed in the last class, the k-means are unsupervised learning. Unsupervised learning. whenever you have data, whenever you have data without labels, then we will be going for unsupervised learning. So what happens whenever we are training the data? What happens? It will be learning the patterns. Whatever the entries, all the entries we are giving, to the model or machine learning algorithm, you can say, ML algorithm. It will go through each and every entry, and it will learn pattern based on the given patterns, and it will come up with one logic. Whether it is any model, whether it is a supervised model or unsupervised model, it will be the same case. It will learn all the patterns and then it will come up with new logic. So for that, we will be needing the historical data. So obviously, for every model, whether it is supervised or unsupervised, you have to go through the pre-processing. You have to go through pre-processing techniques like we have discussed in the earlier session, the previous session. We have to go through all the pre-processing techniques. Once it is done, then you can apply your the data frame, whatever the data frame that you have cleaned, the same data frame you can apply to the machine learning model. And in this class, we'll particularly discuss about the k-means clustering. We'll be discussing only k-means clustering. It is a non-hierarchical clustering. It is a non-hierarchical. It is a non-hierarchical clustering algorithm. So what is a non-hierarchical? Normally, in unsupervised, we'll be having algorithms like hierarchical clustering. So what happens in hierarchical clustering? At the beginning, whatever the entries we have, let's say you have 100 entries. First, you have 100 entries. In that case, you will consider as 100 clusters. At the very beginning, you will be considering as 100 clusters, something like that. Let's say these are your all entries. Let's assume these are not 100, but let's assume it is 100. First, you will consider as 100 clusters. Then, based on the similarity, 1, 2, 3, 5, 6. Based on the similarity, it will group. It will group into clusters. Based on the similarity. How, on which base it is taking similarity? We will be using the Euclidean distance. Euclidean distance between the Euclidean distance means. So whenever there is a data point, these are your 100 entries. Let's say these are your 100 entries. To calculate distance between 2 data points. To calculate distance between 2 points, we'll be using the Euclidean distance. That is x2 minus x1 whole square plus y2 minus y. It is a Euclidean distance. So based on this matrix, we'll be calculating the distance. Whichever the shortest, that will be merged into similar groups or clusters. At the very beginning, it will be considered as let's say n entries you have, n clusters will be considered, and then based on the similarity, it will keep merging into clusters, and at the, finally it will become just one cluster. It is a hierarchical. When it comes to it is a hierarchical. So based on your requirement, you can select any number of clusters you want. Based on your requirement, if you want just 2 clusters, in that case you can draw a line here. If you want 4 or 5 clusters, you can draw here. In this case, you will be having 1, 2, 3, 4 clusters. Here you will be having just 2 clusters. So it is completely depends on your requirement. You can check the clusters, are those making any sense or not. Then you will calculate the mean of those clusters, whether there is any variance between two clusters or is proper, or is it making sense. Those those variance or mean of those cluster is very narrow. In that case, you won't be considering that as a perfect cluster. So we'll be checking the mean of those clusters. Then we will be deciding whether those clusters are feasible or not, or we should go for other cluster. This is all about the hierarchical cluster. When it comes to k-means cluster, what happens? When it comes to k-means cluster, what happens? The same, you'll be having the same 100 entries. So something like that, we'll be having all 100 entries. When it comes to k-means cluster, you have to assign k upfront. How many clusters you want? That you have to assign very beginning. Then only the algorithm will start. But when it comes to hierarchical clustering, it is not the case. First, we will form the clusters or dendrogram. Those are the plot I have shown you, right? Something like this. These are called dendrogram plots. First, we will be doing the dendrogram plots. Based on that, we will be deciding how many clusters we want, based on going through the clusters, whether they are making sense or not. Just by after doing some analysis, we will be deciding this many clusters will be feasible or making sense. Those clusters only will be taking at the end. When it comes to k-means, we don't have something like that. We have to give k value. The number of clusters you want, you have to give upfront only. Very beginning you have to give. Then only you can able to start the algorithm. So how we are selecting the k? Previously in previous times, when it comes to k, it will be decided by this value. K is equal to underscore n by 2. But nowadays it is doesn't make any sense, because previous time you will be having less data. In that case, you can go with this formula. But nowadays you will be having huge number of data. Let's say you have 1000 data. 1000 data. In that case, what happens? It is under root 500. So here clusters are very high. So these many clusters, we won't be able to do anything with that. So what we are doing, we have to go for some alternate methods. That alternate method here is scree plot. Scree plot. How we going to plot the scree plot, we'll see. But before that, we'll check how k-means clusters will be formed when it comes to k-means algorithm. So before starting the algorithm itself, we'll be giving k value something. Let's say you have the k value. You have given k is equal to. In that case, what happened? Randomly, two centroids. Randomly, two centroids will be formed. Let's say these are all our data frames. Randomly, two centroids will be formed. Then what happens? It will calculate the distance between each and every point. Each and every point. It will calculate distance between each and every point from the centroid. It will calculate the distance between each and every point. Then it will choose whichever the near. It will form a cluster, something like this. It will form a cluster based on the average of all these. Based on average of all these, wherever there is an average, or you can say mean, this centroid will change. Let's say you have a mean of all these points or clusters is here. In that case, this centroid will change to from here this place to this. Previously, these are random value. Wherever you are given k is equal to, random centroids will be formed. right after doing the clusters, it will calculate the mean of that cluster and it will change to new centroid. Again, it will calculate the mean and it will change to new centroid. Again, what it will do? Again, it will calculate distance between all the points. Again, it will calculate all the points. Then again, it will do the same. Again, it will calculate the mean of that particular cluster. And if there is any change in that case, again, it will move to new centroid. Like that, it will keep happening. It will keep happening until and unless the mean of that particular cluster, is equal to previous mean. Or you can say the centroid of the new is equal to the previous centroid. In that case, there is no need to change the mean or centroid. In that case, it will become constant. That is how we will be forming the clusters. It is when it is k is equal to, what happens when k is equal to 3? Randomly, it will assign 3. It could be here, it could be here, or it could be here. Randomly, 3 centroids will be assigned. Then it will check all the distance. It will check all the distance from those centroid. What is the distance here? It is Euclidean distance. We'll be using Euclidean distance. Same. y2 minus y1 whole square plus x2 minus x1. Don't wonder, previously I wrote first x2 minus x1. Now I'm writing first y2 minus y1. Yeah, it is pretty same. Okay. Same cluster will be formed. Again, it will calculate the mean of this. Depend on that mean, it will change. It will change its centroid to here. Depending on the means, it will change the centroid to somewhere else. Depending on the means, it will change the centroid to somewhere else. Again, what it will do? Again, it will calculate the distance. Again, it will calculate distance. Again, it will calculate the distance. Based on, again, it will calculate the distance. What happens? Same. Again, it will calculate the mean of those clusters. And if there is any change in the mean, it will change the centroid. Until and unless there is no change in the previous centroid and the present centroid, it will keep moving. And finally, it will become a constant. Then it will form clusters. Is the one cluster or 3 clusters. These are the T3 clusters. When you have given k is equal to 3. If you have k is equal to 4, same, it's randomly 4 centroid will be formed. Again, they will calculate the distance between centroid to all the points, whichever nearest point, it will group into one cluster. Again, it will calculate the mean of those clusters and it will move to wherever the mean is there, it will simply move to that particular place. So it will keep happening. It will keep happening until it becomes constant. So this is how k-means clusters will be formed. Okay. So this is how k-means clustering will work. So how are we going to apply that k-means cluster to our any use cases? So do we have any drawbacks? What are the advantages when it comes to k-means clusters? We already have a hierarchical clustering, right? Then why we are still going for the k-means clustering? What is the difference between that? We'll discuss that. So when it comes to advantage over hierarchical clustering. So when it comes to hierarchical clustering, you won't be able to see when you have 100 entries. In that case, you can simply able to find out how many diagrams you have. you can easily be able to find out just by looking at the picture. What if you have 1,000 data? What if you have 10,000 data? What if you have 100,000 data? Will you able to define, or will you able to just by looking at the picture or dendrogram, will you able to decide how many clusters you want? It will be very clumsy. You won't even able to notice how many cluster it is formed, how many groups it is formed. So it is not possible when it comes to hierarchical clustering, and it is also time taking. It has to make so many calculations. So it is time consuming. The processing time is very high. Processing time, let's say, and you won't be able to say how many clusters you want just by looking at the datagram. Using the k-means, we can avoid that. Anyway, we'll be giving the k value upfront only. So we will keep changing the k value, and we'll change see the clusters, whichever cluster we are forming. Are those? Yeah. Yeah. So right after changing the k values, we'll be checking whatever the cluster we have formed. We'll be calculating the mean of those clusters. If there is a good variance or difference between those clusters are good, in that case you can simply go. So how do we decide this cluster is good and this cluster is not good, and how many clusters you want? See, let's say you have to go for at least 10 iterations from cluster 2 to cluster 10 or 12, something like that. Will you change each and every time and go and check how many clusters we are having, whether whatever the cluster we are having, whether it is feasible or not? Is it possible to check doing the multiple iteration? It is not possible. So we don't be having that much time. In that case, what we can do? We can go for scree plot. So how does scree plot will be formed? First, so scree plot is will be calculated based on the total sum of the square. Total sum of the square. That is called TSS. So what is TSS? So whenever we are forming the cluster, you should make sure that whichever the distance in between clusters. Whenever you are forming the cluster, you should make sure that the distance in between the data sets in cluster I'm talking, it is also called as a within the sum of the square. Within the sum of the square. Sum of the square means it is same, right? x2 minus x1 whole square plus y2 minus y1 whole square. This is the sum of the square. So within the sum of the square should be as less as it could be. So you have to make sure that within the sum of the square in between the data points in one cluster, within the sum of the points should be as less as it can be. You have to make sure that. And when it comes to between the sum of the square, we have one more between the sum of the square. We have one more thing called between the sum of the square. What is that? The distance between two clusters. The distance between two clusters should be as high as it could be, so that we can differentiate, right? So if it is nearby, in that case, you won't be able to differentiate much. This is only variance we are talking about. Whenever the cluster is formed, we'll be calculating mean. What does that mean? Average of these clusters. It should be as high as it can be. Then only whatever the clusters we have formed makes sense. Whenever there is a high variance in between, high variance means high difference between the two clusters, then only these are feasible. These make sense. These make sense. Other than that, it won't make that much sense, right? So this only will be doing multiple iteration and we are calculating that, so that whatever the cluster we are making, forming, it should make sense. So between the sum of the square, BSS, it should be as high as it can be. Within the sum of square, WSS, it should be as less as it can be. So like that, we will be, we should make sure that the distance in between the data points in the clusters, data points should be packed. Should be packed, and when it comes to cluster distance, it should be more. Based on that, we will be having total sum of the square between the sum of the square, BSS, plus within the sum of the square, TSS. Based on TSS, we will be forming the scree plot. In the scree plot, what happens? You have a scree plot. This is a process of we forming the clusters. I'll explain you that too, just a minute. Okay. So total sum of the square. Based on that, what we'll be getting? So you'll be getting a scree plot, something like this. Scree plot, something like this. So these are the k values. And this k values 1, 2, 3, 4, 5, 6, 7, something like that. And this is total sum of the square. So what we are doing here, we are simply plotting the. So we'll be using one loop, k is equal to 1 to, using for loop or into k is equal to 2 to 9. You won't be using the one because we are forming the clusters and you're taking whole data set as one. It doesn't make any sense, right? So it should take at least minimum 2 to 9 or 10. And we are doing the multiple iterations and we are forming the clusters. In that case, wherever you are getting the elbow, let's say here, wherever you are getting the elbow, just take that cluster and nearby those clusters. Let's say elbow you have it 3, then 2 and 4. You have to check for 2 and 4. It doesn't mean like you are getting elbow here. It doesn't mean that is the best or perfect cluster. You have to check nearby as well. Then compare those clusters. Then you will be able to say that which one is the better. I won't recommend you can directly go for k is equal to 3. Instead, check both 2 and 4. Instead of going for like 2 to 9, it is best only, right? You are going for 2, 3, and 4. Instead of 9 options, you have just 3 options. Now you have to go through all those 3, and whichever cluster is performing good or looking good. In that case, you can simply take that as your cluster or the best fit or the best cluster, you can say. Okay. So this is the process how clusters are formed. First, you have to initialize the centroid k value. You can give anything 2, 3, 4, something like that. Based on that, it will simply form the centroids, and then it is calculate the distance. That is Euclidean distance between all those data points, and which is the shortest distance. It will simply calculate the all the clusters, and whichever the mean is there, it will simply shift to new mean. Centroid will be shifted to new mean. It will keep repeating until it will be constant. It will keep repeating until it will become the constant. But we have one thing. So it is k-means cluster is good for when it comes to when you have a high data entries or high amount of data. When you have a high amount of data like 100k or 50k, something like that, in that case, it is the best way to determine your cluster. But it has some drawbacks. Let's say the previous slide. So normally data frame won't be this perfect. This won't be this much this perfect, right? You can't be able to having this perfect data. So what you have to do, you will be having some clumsy data or this something like that. Something like that you will be having. So in that case, what happens? Sometimes whenever you are calculating new mean, some data points, it will keep oscillating in between those two means. So it will be oscillating the first time whenever you calculate the distance between these class points, mean is came here, and then according to that you have changed the centroid. First time it came into this this zone, and the next time it went to this zone. It will keep oscillating in between. There are some cases you might get into this. In that case, what happens? You will be in an infinite loop. You won't be getting any cluster, but it is keep repeating. You would while you are running in Spider, you might be seeing that red color button. So it will be keep running, but you won't be able to get any outputs. It will be keep running. It will keep running, but you won't be able to get any outputs. In that case, what we have to do? We have to fix some iterations. You have to fix some iterations so that the oscillation, even though, see, once it is done, cluster formation is done, just one point is oscillating in between them. So let's say you have 100 iterations, you have given the maximum iterations on 100. More than that, it won't allow. Once 100 iteration is came, if that point, if it is in this cluster, it will take into this cluster only. If it is in this cluster, it will take that cluster, and then it will stop. Then it will stop. So you have to give some iterations. You have to give some iterations. And one more case is that whenever you are changing, whenever you have, let's say, first time you have formed clusters. If you run the same algorithm again, you will be getting different clusters. You will be getting a bit not completely same, exactly same, but you will be getting some difference in your cluster. Each time you will be whenever you are running now, it will give you a different cluster, a minor variations. So it is also one drawback. Then whenever we are considering the k-means clustering. Yeah. So where we will be applying the this k-means whenever you have a just a minute, guys. Oops. Network. Yeah. Yeah. So when we will be going for clusters, what is the advantage over the hierarchical cluster? We have seen, right? So exactly where we will be using whenever you have a large data set. Whenever you have a large data set, you can simply apply the k-means clustering. And it is also computationally expensive since it has to go through so many. You have to go through so many computations. Still, but it will be giving the best clusters compared to previous that hierarchical clustering. In hierarchical clustering, you won't be able to tell when you have you might have, if you have done some assignment based on hierarchical clustering, you might have come across that even though you have like 10,000 data, it will take a lot of time to plot the dendrograms. It will take a lot of time to plot a dendrogram. So it will take a lot of time. Let's say you have 100K data. In that case, you have to wait at least 8 minutes, 8 to 10 minutes to form a dendrogram. So it is not the best way to go for hierarchical clustering when you have a large scale data. And anyway, we'll be using the scree plot in order to determine how many clusters you want. In that case, you can easily find out how many clusters we'll be wanting. You just need to go to 2 to 3 cluster values. If it is where you are getting the elbow part, it is k is equal to 2. In that case, you can simply check 3 and 4. That's it. Just 3 iteration and you'll be good. You can just check your cluster and you might be finding the best cluster for your data set. Like we have discussed previously, we have to what are the limitations? We have to give the cluster upfront only, then only it will be starting. Outlier, and yeah, when it comes to outlier, it will be having the strong influence when it comes to on results. Because why clusters the outliers will be having the high influence on the k-means. K-means. Why? So name itself saying we will be taking the mean average. Whenever average comes in, it will be having the high influence of outliers. If you have outliers in your data, it will be influencing your mean a lot. So you should be careful whenever you are doing the whenever you are going for k-means clustering. You should be careful that you have done your pre-processing. In that, you have to clean all those outliers. Then only it is recommended to go for model building. And in k-means, we'll be having so many different types of clusters. Depending on your requirement, you can go for different clusters. In that, you'll be having density curve. When you have a parabola, in that case also you'll be having different technique variations we have when it comes to k-means clustering that you can go through based on your requirement. So we have already discussed why what are the when it comes to k-means clustering, we have few things that you have to take care of whenever. For stability run, the k-mean clustering multiple times call the iteration with the different randomly chosen k values will address the multiple local minimum. Whenever you are running the algorithm, each and every time, it will keep changing. So you should be aware of that. Same, you have to take care of the sum of the squares. Within the sum of the square and between the sum of the square. Combining both, it will be total sum of the square or sum of the square. Yeah, and now we will see one use case and how we're going to apply our k-means algorithm on our data set. So when it comes to the use case that we are doing today, it is forming clusters, whether that particular person has a diabetes or not. we have taken this data frame from Kaggle. You can simply go and check the diabetes data frame or data frame or data set. You can simply take the data frame from Kaggle and you can open it. So here, what I'm taking, I will be taking the supervised. Supervised means data with the labels. We'll be having different inputs, and we have a labels. Why I'm taking labels? I'll be forming clusters based on labels as well, so that we can see whatever the cluster we are forming, is it near to that real cluster or not. I'll be taking the labeled data, and we'll check both whatever the cluster I formed are, and before the data, after the cluster formation using prediction and previous historical data. We'll check both. We'll compare how similar both the data are, how similar both clusters are. See, we'll be doing the very base model, very basic model. If you want to tune a bit, and you can increase the accuracy and all, but for explanation how do we apply the our k-means algorithm when it comes to healthcare analytics, we'll be taking one base model and we'll work on it. So here is same Euclidean distance, how we are calculating the similarity between 2 points that we have been here. So we are applying the k-means clustering. Yeah. First, what we have to do, we have to go through all the libraries whichever we want to use. Here we are importing the pandas. What is pandas do? It is in order to do data manipulation. See, if you want to do changes in your data, any changes, whether you want to change column name, whether you want to do some pre-processing techniques, whether you want to impute your missing values, all those things will be taken care of this library class called pandas. And we'll be importing the NumPy as well. NumPy, what does NumPy do? Whatever the mathematical calculation will be doing. Mathematical calculation, all the mathematical calculation. And if you want to, store the data in the form of arrays, that also we can do using the NumPy. And here I'm importing the matplotlib as well. See, these are the import pandas as PD. It is pandas, but in a short form. I don't want to use pandas again and again. I'm simply using the PD, and I can make use of that library. That is why I'm importing pandas as PD. And when it comes to NumPy, import NumPy as a NP. And here import matplotlib.pyplot as a PLT. Why we are importing the matplotlib? Because I'll be using the visualization. It is a visualization library. Yeah, it is a visualization library. Whenever you want to visualize something, in that case you have to use the matplotlib. One more, we will be having Seaborn as well. Seaborn library. It is a bit advanced visualization, but matplotlib is okay. If you want to go for advanced visualization, you can go for that too. But for now, matplotlib can do our work, so we'll be going for that. Anyway, we have imported dataset import panda, so it is not necessary. So here I'm importing the sklearn. From sklearn package, I'm importing the preprocessing. Whatever the preprocessing we'll be doing, it is present in our Scalar. And here I'm importing the standard Scalar. Standard Scalar. What is standard Scalar? Whenever you have a data, that is, let's say x1, x2, x3, x4. You have a different data. and there is a huge variation in between input columns itself. Like if it is 0.5, 0.9, 1.2, something like that, it is 10, 50, 25, 15, like that. It is 1000, 1200, 1500, 1, 2, 3. See, each has different scales. So whenever you are doing prediction, in that case, there is a possibility that it has higher effect. There is a possibility this column might have a higher effect for predicting that particular prediction. Any prediction you are doing, it will have a high effect because these values are very high. In order to avoid that, in order to avoid the biased prediction, we'll be going for standard scalar. Standard scalar. You can go for normalization as well. Normalization. Both do the same thing, but when it comes to normalization, all the values are converted in between 0 and 1. When it comes to standard scalar, the values are ranges from minus infinity to plus infinity, but the mean value will be equal to 0 and standard deviation is equal to 1. So what we are doing, in simple words, we are simply scaling all the different scale. We are converting into single scale or making scale free data, scale free. How we are doing, we'll see. So min-max scalar, it is pretty much same. You can use any one of those. You can use min-max scalar or standard scalar. It will do the same thing. So these are the libraries that we are having. So here we are having the data, that is the CS. I mean, whatever the data will be having, I'm just saving into data. I'm just importing that data frame or data set, you can say. I'm importing the data set, that is data.csv. I'll be having that in our folder only, local server, and I'm importing using the data pd panda.read_csv. panda.read_csv. I'm reading the data frame using the pandas. So whenever you say head is equal 10, first 10 entries, whatever the first 10 entries will be having, it will be displayed. So these are the first 10 entries. What are the columns we have here? Pregnancies, glucose, blood pressure, skin thickness, insulin, BMI ratio, that is a body to mass index ratio, diabetes, pedigree function, age, and outcome. Here it is outcome is a label column. We are not supposed to use when it comes to unsupervised learning. I just want to check whichever the clusters I'm forming, is it near to the actual cluster? I'll be taking this data frame and I'll be forming the cluster using the label. And then I'll check just taking the without label. I'll take without label data frame. Then I'll form the cluster and compare both. How the actual cluster is here and how my cluster came out. How whatever the cluster we are making, how it is turned out, we'll be simply comparing and we'll see. Yeah. So normally, just check if you have how many columns you have, something like that. Simply run it. You will be getting 68 entries we have in that 9 features. 9 features means 9 columns we have. These are the features. These are also called as features. All the input variable. These are also called as. We have different names. Features, independent variables, independent variables, and input columns also we can call. Something like that. We'll be having different names. It is our outcome. It is also called as a label. You can say label or dependent variable. Dependent. These are independent since these are independent of anything, but outcome is completely dependent on these independent variables. So we'll be calling these are the dependent. These are independent. Yeah. So this is our shape of the data frame. So I will do the basic pre-processing. If you want to, guys, you can simply download and you can do some tuning as well. But I'm simply going through how we can apply the healthcare analytics and using the K-means. So I'll be doing the basic pre-processing data types. So these are the data types we'll be having. Float. Most of the data frame will be having in numeric only. So that what we can do, we can simply do the describe function. What does describe function do? It will simply tell you which are the how many maximum. What is the maximum value? How many entries you have? So count how many entries you have. You have all the entries. What is the mean? What is the standard deviation? What is the mean? Minimum value? How many values you have in between 25 percentile? How many values you have in 50 percentile? How many values you have in 70 percentile? It is percentile, not percentage. It will be shown. It is the maximum value. What is the maximum value in each and every column? It will be showing that. So I'm just checking whether we have any null values in our data set or not. So we don't have any null values present in our data set. So we can simply go for info. Info, it will give all the details about how many columns you have, how many entries you have, whether you have any null values or not in your entry, how much memory it is taking, all those things will be displayed. These are the how many entries you have, whether you have any null values or not. These are the columns, how many columns you have, there are features, it will display. So here you don't need to check that whether you have any balanced data or not balanced data, but just did so that I can apply to supervised learning. So just I want to apply for supervised learning. See what happens. What is balanced data, unbalanced data? You should need at least one of the class when it comes to output. At least 30% you should have in one of the class. In that case, we will be considering as a balanced data. Some people go for 40. Some people even go for 45. But thumb rule is you have to have at least 30% of the class. Here what we have 0 and 1, benign and null. Yeah, whether you have diabetes or not. We having two classes. In that, one class is 500, one is 260. 80 pretty much balanced one, so no problem. But some people go up to 45, 40 in order to get better accuracy. So even 30 will be taking as a balanced data. You don't mind. So it is the output column. Whenever you are going for unsupervised learning, you don't need to do these things. But anyway, I'm applying the same thing for supervised as well. So these are the outcomes of our diabetes. Whether you have any output, how many people have a diabetes, how many people don't have a diabetes. Yeah, I'm just checking whether the columns and do we have any null values. We don't have any null values. Okay, here we have. NA values, null values are pretty much same only, but here we have NA values are these. So whenever we are working on healthcare analytics, just one suggestion from my side. Whenever you have a healthcare data, you have null values in your data set. Don't just simply go for mean, median, mode imputation. Don't simply go for mean, median, mode imputation. Please don't go for it, because see, each and every entry is different people, different person. Every person won't be having same health conditions, right? Some people have something else, some people have some other health conditions, some people have some are healthy. These are completely individual. You won't be randomly because here 300 values are missing. You can simply go for mean imputation and then do the extraction. It doesn't make any sense when it comes exactly just for healthcare analytics or life science analytics. You can go through it. If it is making sense for you, in that case, you can go ahead. But most of the time it doesn't make any sense. So you should be very careful about it. Anyway, here I'm just for showing purpose, I'm doing the mean median mode imputation. Normally I don't recommend, but for just showing purpose, I'm going for mean median mode imputation. So I'm just replacing everything with mean imputation. And here I'm applying the scalar in order to bring down to all those into single scale. Here I'm bringing down to everything into single scale. I'm bringing down everything into a single scale. So in that case, you can see all will be using min-max scalar. So here everything in between 0 and 1, all the columns, whichever the column will be having, it is simply in between 0 and 1. And then you can go for feature importance also. Which are the features are best? I mean, based on that, you can do some decisions. See, whichever the column is more important for your data set, just look at it. You'll be finding this is the importance. It will be increasing. So whenever you have a high importance, in that case, you can consider those columns. If you don't have any info, I mean, if one particular column is not providing any information, in that case, what happens? You don't need to take that column, or you can simply ignore that column when it is not giving any information for you to predict something. In that case, what you won't be able to do anything with the data or with that feature. So you can simply check which are the, whenever we are working on supervised data, it is most recommendable. But even though when you are going for hierarchical, just check it. Which are the features you are having the important, giving the highest, which is having the highest importance. Simply go for it. And you want to do correlation between all those. You want to find out the correlation between all those columns. You can find out. Here we'll be having good correlation, BMI and skin thickness. Mixed, we have some mixed reaction from here. Here we have a good correlation between skin thickness and it is pretty much same, I guess. Yeah, BMI, the same BMI. Just to see how related your whatever the features you will be having. Just go through it. Okay. So in order to find the best key values, I'll be running one algorithm. Here I'm just splitting into X and Y. So normally in K means you unsupervised, you don't need to do that, but I want to compare both previous output and actual output, and previous output, whatever the predictor one and previous one, historical one. I want to compare both. That is why I'm splitting into X and Y. Here it is the clusters will be having. The clusters or output will be having in the very first. These are the X and these are Y. Normally you don't need to do that, but I just wanted to compare both. That is why I'm doing split. You can just go through the shape and all. You can simply import the k-means. Here I'm giving the cluster is equal to 2. And then I'm checking the mean of those clusters. We'll be considering just 3 columns based on the feature importance. We have seen that which are the best features. So I'm considering just 3: glucose, insulin, and BMI. Based on that only, we'll be deciding whether we'll be having good clusters or not. So based on feature importance, I'm taking just 3. You can do some changes. You can work on it, but it is very base model, like I said earlier. Yeah, for supervised you don't need it, but yeah. So this is the actual cluster. Once we have done with that, it is the actual cluster and it is my predicted cluster. So it is a 3D, but you won't be able to form all the clusters. So you have to, it is a basic model. You can do some tunings and you can come up with it. So this is the one of the use case scenario, guys. I hope you guys learned something, using the this use case scenario. Try to apply the same in your try to apply, import the same data frame and try to apply your own strategies and make it better. So yeah, that's it, guys. I hope you guys learned something from today's class. And yeah, if you want to see more of these videos, you want to know more of this use case scenario when it comes to healthcare analytics, tomorrow we'll be having one more class. We'll be using one more use case scenario using the linear regression. If you want to, you can join with us in the next session. And yeah, thank you for guys. If you have learned something, please try to follow our LinkedIn channel, and we'll be having the Telegram channels as well. You can simply search healthcare analytics, and you will be getting one page. You want to see more of this kind of use case scenarios, you can join. Yeah, that's it for today, guys. I hope you guys learned something, and we'll see you in the next class, and have a nice day.